Remove all occurrences of duplicates in a linked list. First of all, we'll try to understand the problem statement. So over here, I have written down one of the linked list given to you in the input. So you will be given the value of n denotes the how many number of nodes are present in the linked list or the size of the linked list, and you are given an entire linked list. So what you have to do, you have to remove all the duplicate nodes in the given input linked list and then return the linked list containing only unique nodes of the input linked list. So over here you can see in this linked list 23 is occurring only once, so you have to keep 23. 28 is occurring twice, right? It is having some duplicates, so you have to remove 28. And then this 35 is having it is unique, right? So you have to keep 35. 49 is having duplicacies, so remove 49, and then 53 is also having duplicacies, so remove 53. So after removing all the duplicates in the given input linked list, you are left with only two nodes, 23 and 35. So in the output linked list, you can see it contains 23 and then 35. Also, you have to maintain the occurrences of the nodes. You should not return a linked list in which 35 is occurring before 23. So this is wrong and it will give you wrong answer. It will be not accepted. So this is the question. I hope you have understood the question. It is pretty easy to understand what the question wants. So now let's understand what the brute force approach can be. So first of all, over here from this I can think of something which contains uniqueness, or I can count the frequencies of each and every nodes. So what I will be doing, let me copy this. So what I can do in the brute force approach, I can keep track of each and every linked list, or to be precise, each and every nodes and how many times they are occurring. So for that I can use a hash map, or you can use anything else in your language similar to hash map or map in C++. So first of all, I'll iterate over each and every nodes in the given linked list. So I'll keep one variable current which will be iterating over each and every nodes in the linked list, and simultaneously I'll keep the track of the data of the nodes, that how many times this data is occurring. So current is pointing to 23, so I'll make an entry in the map that 23 is occurring once. Then current will be iterating and current will be pointing to 28, so I'll make an entry that 28 is occurring once. Then again I see a 28, so I'll increase its frequency count by 1. So next is 35, so I'll make an entry, it is not present inside my map, so 35 is occurring once. Then again an entry of 49, because it is not present, 49 is occurring once. I see 49 again, so 49 frequency will be increased by 1. So I can see 53 not present in the map, so make an entry with value 1. So again a 53, so increase its frequency by 1. So I can see I have counted the frequency of each and every nodes present in the input linked list. So now what I will be doing, I will be taking the help of a dummy node. I'll be creating a linked list with the same nodes of the input linked list, but I will not be creating an entire node again and again. So let me take a dummy node. So this is my dummy node which is having the value equal to -1 initially. So dummy node will be the head. Currently it will be the head of all the unique nodes which are present. Okay, so I'll be keeping on appending the nodes which are having frequency 1 at the end of this linked list, which is having the head as dummy node. Okay, so now again I'll be iterating over the entire linked list again. So starting from the head of the input linked list, that is from 23. So I can see that 23. So what I'll be doing, whenever I encounter a node, I'll check in this map whether that node is having frequency 1 or not. Okay, so if it is having a frequency, I will immediately append this node to the end of the dummy linked list. Okay, so I can see 23, right? 23 is occurring once, so I will remove 23 from here and I will append it at the tail of the linked list, and I will keep a one variable, right, because I need the tail of this new linked list each and every time, right? So this temp will be pointing to the tail of this new linked list. Remember that we are not creating the new nodes, we are just changing the references, we are changing the pointers of the nodes. So now moving on further, so the next element is 28, so I'll be checking the frequency of 28. 28 is occurring twice, so I'll be ignoring it. So again a 28 is occurring, so its frequency is twice, ignore it, right? So now I will be moving further. 35, I can see 35 is occurring only once, so append 35 at the tail of this new linked list. So 35 is over here, and temp will be moving on further. So now moving on further, so the next element is 49. 49 is having frequency 2, so ignore 49. 49 again, so ignore 49 because its frequency is 2. 53, what is its frequency? Yes, it is equal to 2, so ignore it. Again 53, its frequency is equal to 2, so ignore 53 again. So here you can see I have created a new linked list, right? So over here the answer lies at the next of the dummy node. Whatever is present at the next of the dummy node is my output linked list, is my answer linked list. So what I will be doing, I will be removing this dummy node, and then I will be returning whatever is left after the next of the dummy node. So that is how you can do the brute force approach. So talking about the time complexity, if you observe carefully here, how many times I have iterated the linked list. So I can see that in order to create the frequency, in order to get the idea about the frequency of each and every node, I have iterated over the entire linked list once. So order of n, right? Plus I was iterating again in order to get my output linked list, right? So again the iteration will be taken n number of times, right, over the entire linked list. So the time complexity comes out to be order of n plus n, or I can be precise to be I can say that it is order of 2n. The time complexity is order of 2n, or I can write it as order of n, removing the constant. And talking about the space complexity, over here you can see I have created a map. So and what are all values are present inside the map? The values of the nodes are present inside the map along with their frequencies, right? So what is the maximum number of elements which can be there inside the map? So at max, in worst case, assume a linked list which is having all the nodes unique. It is not having any duplicates. So all the nodes are unique, right? So that means the size of this hash map will be equivalent to whatever is the value of n. So the space complexity in this case comes out to be order of n, and I am not creating new nodes over here. So this is a constant space requirement for creating the new linked list. So this is how I can achieve the brute force algorithm. So now we'll take a look at the Java code, but the same thing can be implemented in the other languages as well. So this is the Java code for the brute force approach. So first of all, what is the requirement? I need a hash map, right? I need a hash map to get the frequency of each and every node. I have created a hash map and it is called map. And then I need to iterate over the entire linked list. So the current pointer will be iterating over each and every node of the linked list, and then a simple while loop until and unless all the nodes of the linked list have been visited once, right? And then making an entry inside my map, I have used some kind of modification over here. You can use if else condition in order to achieve this. Okay, so what I'm doing, I'm putting the value of the current node inside my map plus 1, whatever is the frequency which is already present inside the map for the current node, plus 1. Or else if it is not present inside the map, then its default value will be taken as 0 and 1 will be added, so its frequency for the first time will be equal to 1, and then moving my pointer current further. And then I have created a dummy node which will be the head of our new linked list, in which we are taking the in which we are appending the nodes of the input linked list only. We are not creating new nodes. So temp will be pointing to the tail of this new linked list, right, which is having head as dummy node. So current will be again pointing to head, so I need to iterate over the entire linked list again. So now what I'll be doing, I'll be iterating, and whenever I come across a node, I'll be checking whether its frequency is equal to 1 or not. If its frequency is 1, then that node is of our use, so I'll be appending that node till the to the end of this dummy node linked list. So I'll be making the next of temp, which is the tail of this new linked list, point to the new node, not the new node but the node which is taken from the input linked list, and I'll be moving my temp further because I have appended a new node at the end of this linked list. If this is not the case, what I will be doing, I will be simply ignoring and moving my current further. I have written down this as temp.next is equal to null because as I'm taking the nodes from the input linked list only. So in the input linked list, that node will be pointing to the next node of this input linked list. So I'll be breaking that link so there won't be any kind of confusion, or no extra nodes will be added to this final output linked list. So that's why I'm doing temp.next is equal to null. And then after iterating over each and every nodes of the input linked list, I will be simply returning the next of the dummy node because that is going to be the head of our output linked list. So this is the brute force algorithm on how to remove all occurrences of duplicates in a linked list. So now we can take a look at the optimization of this approach. So in order to optimize this, what I can do, the time complexity over here was, to be precise, order of 2n, right? Time complexity was order of 2n. So I can do it in a single iteration, and along with this, the space complexity can also be optimized. So I do not need to use this hash map in order to take care of whether that node is a unique node or not. So we'll optimize it and see how we can achieve it. Okay, so now let's take a look at the optimal approach. So first of all, I need to modify something in order to achieve the optimal approach. So we'll be converting this brute force approach to optimal approach. So over here, I was using something extra that is called the hash map. So if I want to know whether the node is unique or not, I need some replacement of this hash map. So in order to replace something by hash map which will not require a size equivalent to the input size, so I'll be using a flag variable. So this flag variable will be declaring whether the node which I am currently seeing is a unique node or not. So flag will be currently, whenever you are seeing a node, the value of flag for the first time is going to be false, and as soon as you come to know whether the current node which you are seeing is a duplicate node, the flag value will immediately change from false to true. That indicates the node which you are seeing is a duplicate node, so you have to ignore that node. Okay, and what about the dummy node concept? So dummy node concept will be also used inside the optimal approach. So we have reduced our space complexity. So I have replaced this hash map by a flag variable, so our space complexity will also be reduced, and let's see what can be the space complexity at the end. So I'll be using the flag variable. And what about the number of iterations? So if I'm not creating the frequency array or the map for the entire node or the entire linked list, then that means one of the iteration will be reduced that I was doing in order to create the entries inside the hash map. So the space time complexity will also get reduced. So we'll take a look at the end what will be the time complexity. So I'll be using a single iteration over the entire linked list. So how will I identify whether the node I am seeing is a duplicate node or not? So if you read the problem statement properly, it mentions that the linked list is in sorted manner. The linked list is going to be in sorted manner. So if you have a number of elements, right? If you have n number of elements, and there are some duplicates, and that entire set is sorted in increasing or in decreasing order, any order, then that means the duplicates are always going to be adjacent to each other. Similarly, as this linked list is in sorted manner, the duplicate nodes are going to be adjacent to each other. If you observe carefully, here you will be able to observe that the duplicate nodes are adjacent to each other. So if I want to know whether the node which I am seeing is a duplicate node or not, then I can simply compare its value. Let's say I was targeting 28 and I wanted to know whether this 28 is a duplicate node or not. I can simply check the value of the next node after 28. If both of them are having the same value, then that means it is a duplicate node. So now let's see how will I solve this using the brute force approach. So I'll be using a current variable or current pointer which will be pointing to each and every node of the linked list, and I'll be using a simple one iteration over the entire linked list. So current is currently pointing to 23 and flag value is equal to false. And the concept about dummy node and temp remains as it is. Temp will be pointing to the tail of the new linked list. And remember one thing, not creating the entire node each and every time, using the node of the input linked list only. So flag is currently false for the current node 23. So I will be checking whether this current node 23 is duplicate or not. So for that, what I'll be doing, I'll be comparing it the value of the next node. So I can see the next node is not having the same value as 23. 23 is not equal to 28. So that means the 23 is a unique node. So if 23 is a unique node, what I need to do? I need to append this node at the end or the tail of the dummy node linked list, and this temp will be moving on further. So temp is currently pointing to 23. Temp is currently pointing to 23. So now I will move my current pointer further. So current will be pointing to 28. Now current is pointing to 28 and flag value still flag value again will be reinitialized. If it was true or anything, it will be reinitialized to false for as it is a new node. So 28 is having flag value equals to false. I need to check whether it is a duplicate node or not. So I'll check the next node. 28 is having the next node 28. So 28 and 28 both are equivalent. They are both equivalent. So I'll take my current pointer further because I need to ignore the current node 28. So I'll take my current pointer further. So taking on current pointer further, I can see I have 28. So I have taken my current pointer further because I need to remove all the duplicates, right? So it is possible that there can be more number of duplicates, more occurrences of 28 like this. So all these occurrences needs to be removed, right? So your current will be initially at this first occurrence of 28. So in order to remove all the occurrences, take your current pointer to the last occurrence of the duplicate node. So the last occurrence of the duplicate node, I have taken my current pointer at this point, right? So now moving on further, I have ignored this 28. I'll be not appending it over here. So now moving on further, 28 entire occurrences of 28 has been ignored. So now I can move current pointer further. So now current is at 35. Current is pointing to 35 and my flag value is equal to false. For each and every node, the flag value will be reinitialized to false. For all the new nodes, 35 is a new node. I need to check whether it is a duplicate or not. Check the next elements, next node's value. 35 is not equal to 49. That means this 35 is the node of our interest. So I will append it at the tail of this linked list, dummy node linked list, and moving my temp further. So temp will be pointing to 35. That is the tail of this dummy node linked list. So now I have taken care of 35. So moving on further, so next current will be pointing to 49. Current is pointing to 49. Current is pointing to 49, and I need to end our flag is equal to false. I'll be checking whether this 49 is repeating or not. So check the next elements value. 49 is having next, which is equivalent to 49. So our flag will be changed from false to true. So flag value has been changed, and our current iterate over all the occurrences until and unless you reach the last occurrence of 49. So last occurrence of 49 is over here, and your current will be pointing over there. This 49 has been ignored. So now move further. So current is over here. So current will now point to 53. So your flag will be reinitialized because it is a new node. So your flag will be equal to false. So current is equal to 53. I need to check whether this is a unique node or not. So I'll be checking its next node's value. 53 and its next node value both are same. So your flag will be changing from false to true. That means you need to ignore all 53. I mean all the nodes having value 53 and take your current till the last occurrence of 53. So last occurrence of 53 is over here. So your current will be pointing, and this, as the flag value is equal to true, you will be not appending the node pointed by current to the tail of the dummy node linked list. And now this is 53 has been ignored. So let's see, are there any new nodes or not? And now you reach the end of the linked list, and your current will be equal to null, and you have iterated over the entire linked list only once, and you got your final linked list over here. So you can simply return the next of the dummy node, and your output linked list will be containing 23 and 35. So this is how I did solve the question in one iteration. Over here you used only one iteration, so the time complexity is going to be order of n. And how many space, how much of extra space did I use? I used nothing except the dummy node. A single node has been created and a single boolean variable was created. So the space complexity is not dependent upon the input size. So the space complexity is constant in this case. So now we can take a look at the implementation part of this brute optimal approach. So I have written down the code in Java, but the same thing can be implemented in other languages as well, in C++ also. So first of all, I have created a dummy node. In the brute force, what we did in the first step was creating a hash map and writing down all the frequencies of each and every node inside the hash map. So we are ignoring that part, right? So directly creating the dummy node, and then the stamp will be pointing to the tail of the dummy node. Now I need to iterate over the entire linked list. So current will be iterating over the entire linked list, right? Current will be pointing to each and every node. So flag for each and every unique node for the first time is going to be false. Whenever you encounter the node for the first time, the flag will be initialized to false. and I need to check whether that node is a unique node or not. So you will be comparing the next of the current node. But before comparing, you should check whether the next of the current node exists or not in order to avoid the runtime errors, right? So current.next is not equal to null. That means next exists for the current node. If it is existing, then you will be comparing the current node's data with the next node's data. If they are same, then what you need to do, first of all, you know that flag value will be changed from false to true, right? That means the node which I have seen for the first time is a duplicate node. You need to ignore all the occurrences. So in order to ignore all the occurrences, you will take your current pointer to the last occurrence of that duplicate nodes. So your current will be moving on further, and it will be at the end pointing to the last occurrence of all the duplicate nodes. If this is not the case, you have encountered a unique node, then what does that mean? You need to append this node, remove from the input linked list and append it to the tail of the dummy node linked list. So that will be indicated by your flag variables value. If flag variables value is equal to false, then that means you are encountering a unique node. So if it is a unique node, temp will be pointing to the current node which you are seeing, and temp will be moving to the next node, that means to the tail of the dummy node linked list. And then your current, if this is not the case, that means you have seen a repeated bunch of linked lists or duplicate linked list. That means your current will be pointing to the end last occurrence of all the duplicates. So your current for the next iteration should move to the new node. Current will be moving further, and your temp.next will be equal to null because I am using the same node of the input linked list, as the same node will be pointing to the other nodes in the input linked list. So you need to make your temp equal to next of temp as null. After iterating over each and every nodes of the linked list, you have the final output linked list as the next of the dummy node. Next of the dummy node is the head of your output linked list. So directly return the next of the dummy node because it is going to be your output linked list head. So this is the optimal approach for removing all the occurrence of duplicates in a linked list. I hope you have understood the question properly and also the implementation part. Thank you.